This example comes out of section 1.3, one-sided limits. To begin with, we're asked to consider this function. Now, this is a weird-looking function. In your previous courses, you may not have run into something like this, but it basically defines the function in two pieces. F of x is equal to x squared if x is less than or equal to 2, and f of x equals 7 minus x if x is greater than 2. So the first thing we want to try to do is sketch this thing, draw this graph. And so, if you have axes, we do know what y equals x squared looks like. Just as a side note, it's just a parabola that looks like that. And we do know what 7 minus x looks like, because it's got a y-intercept of 1, 2, 3, 4, 5, 6, 7, and a slope of minus 1, so it looks roughly like that. Basically, we're combining these two graphs, and they meet here where x is equal to 2. So 1, 2, negative 1, negative 2. So I have myself everywhere from 1, 2, 3, 4. 2 squared is 4. 1 squared is 1. 0, etc. So I've got my parabola everywhere from here to the left, including this point at 2, 4. Because of the fact that x is less than or equal to 2 for that part of the function. Now 7 minus x, if I look at when x is equal to 2, the answer to that function would be 5. So I would have a value of 5, except it's not filled in because it's not actually on the graph, and then I end up with a line with a slope of negative 1 heading down that way. So the graph looks something like this. We're asked questions like, what's the limit as x approaches 2 from the left of this function? What's the limit as x approaches 2 from the right of this function? And then the overall question of what is the limit as x approaches 2 for this function. So notice this notation here with the 2 and a little minus up above it. It's not negative 2. It means as you approach 2 from the left. So if I follow this function in from the left side, as I approach 2, this function is approaching a value of 4. So the answer to that left-sided limit, one-sided limit, is 4. Now, as I approach from the right, that's what the 2 with the plus means. As I approach from the right, as I head towards 2, the answer to this thing is 5. Heads towards a value of 5. Now, those two are not equal to each other, which basically tells me immediately that the two-sided limit does not exist. And you'll run into the short form DNE for does not exist. The two-sided limit can't exist if the left-handed and the right-handed limit aren't giving you the same answer. So this graph is definitely not continuous, and that's another little side little definition I'd like to add here is about continuity. This graph is continuous everywhere except at this x equals 2 point. And basically, if a graph is continuous, f of x is continuous at x equals a if and only if f of a is equal to the limit as x approaches a of the function. So in this case, for example, f of 2 does exist. F of 2 gives me an answer of 4. There is a point on the graph when x is 2. So that's the first piece of continuity. So it's possible that this thing could be continuous. There is a point at x equals 2. But the limit as x approaches 2 of f of x, not only does it not equal 4, it doesn't even exist in the first place. So definitely this graph is not continuous at x equals 2. So f of x is not continuous at x equals 2. And we'll see some other unusual piecewise functions that are defined in little pieces like this, and we'll be asked left-handed, right-handed, and two-sided limits. And your Chapter 1 assignment has a few of those right at the start.